The topic is about HVDC grid topologies. What are the HVDC grid topologies that we have known for HVDC transmission? Multi-terminal HVDC grid topologies powering the future of energy and transmission. However, to reduce the losses, the modern engineering have changed for HVDC transmission lines. Why multi-terminal HVDC grid matters? Large-scale renewable integration. The HVDC grids are crucial for integrating vast offshore wind farms and remote renewable energy source into existing power systems, enabling the significant shift towards ever greenery energy mix, efficient long distance transmission. These grids offer comfortable, high efficient transmission of electricity over long distances, minimizing energy losses and making a transport power of generation through rich areas and remaining centers, uh, enabling future super grids. They are a key enabler for development of cons- continental 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 supergrids, even though the intercontinental supergrids linking the asynchronous AC systems across diverse religions and countries, having the grid stability of energy security. From point to point multi-terminal HVDC, on the right side we can see the diagram of HVDC transmission systems to the converter 1 and converter through rectifier. There are total 3 to 4 types of HVDC transmission systems: monopolar, homopolar, bipolar, and back-to-back system, and multi-terminal HVDC system. Total 5 types. The historical high voltage direct current HVDC transmission relied on two terminals points and links, while efficient modern direct connections between two specific points. These systems offered limited flexibility and redundancy, restricting their application in complex power networks. The evolution of multi-terminal HVDC represents a significant leap forward by interconnecting multiple converter stations by MT HVDC system, allowing the dynamic power flow through the enhanced grid reliability and adopting the various varying generations and demanding profiles. Voltage source converter and technology, it has been critical in the evolution. Its supervisory control over the capability inherent bidirectional power flow and make the modern applications through the DC transmission positive polarity. Main MT-HVDC grid topologies are radial topology. This topology features a star-like configuration where multiple terminal connected to a center point. It is a reliability simple in design but offers limited endurance and having HVDC often sustainable smaller network. The specific application requirement for direct connection from the central hub. Uh, Topology that characterized by the interconnected loops and having the high level of reliability operational flexibility. This configuration is ideal for large scale offshore which winds farms and as of withstand multiple scenarios of continuous power supply. Ring topology, the ring topology ex- exemplified by systems like two wind farm, series resonant converter 2WF and SSRT converter combines the benefits of both radial and different design of optimizer endurance and fault tolerance, offering balanced approach for specific grid development needs. Technical challenges in empty HVDC grids, uh, DC fault detection and isolation. The rapid detection and isolation of DC faults are uh, paramount. This requires the development and de- deployment of ultra fast DC circuit breakers, which is about 350 kV breaker and prevent through the outages and protect critical infrastructure. Control complexity according to the multi-drive DC system. The vast grid presents significant control challenges, ensuring stability, voltage, and performance of power sharing among terminals, especially during dynamic conditions require sophisticated control algorithms. The standardization of interoperability, the integration of multi-vendor equipment within a single empty HVDC, multi-terminal HVDC grid, that common communication protocols, prevention schemes, the operational stands that ensure the seamless interoperability and grid stability. Regulatory course for coordination for transmissional empty HVDC grids. The regulatory frameworks boost often closer coordination among different jurisdictions are essential for planning, constructing, and operation across national borders. Advance in converter and protection technologies. We can see the different types of converter and their waveforms in the left side of the uh, presentation. The voltage regulation and time with constant of different converters. Modular multi-level converters MMC. These advanced converters highly scalable for robustness and providing superpower control. Full bridge converter is a significant HVDC system where DC falls without major disturbances. The HVDC gas insulated switchgear also offshore the substations and critical space that reducing the environmental impact of offshore grids, DC breaker and control systems, ongoing process and multi-vendor registration that needed for empty grids, proving that the way integrated the resilient power breakthrough circuits. Real world empty HVDC projects and pilots. China grids is having Xiang project 5 terminal 400 MV and the project 4 terminal 3 gigawatts measured as show share leaking the benefit of a large scale empty HVDC system. The UK project having the different types of system terminal and German and also North Sea wind power hub. These are all common in these different types of multi-pilot projects. Uh, Control strategies over empty HVDC grids, coordinate voltage and power control. Advanced control schemes are implemented in the insurance of voltage and power across all the terminals, maintaining grid stability and optimization power of varying conditions. Adaptive drop control mechanism are employed facilitate optimal power sharing, particularly important for grid and high penetration of renewable source like wind power. This source is also capable for services including overall releases of power systems and simulation and validation. These are also extensively religious for having analyzation and validation for new control strategies, ensuring reboot and reliability grid operations. The road ahead future developments in research. We can also see the HVDC transmission system is a wide range of reliability across various driving conditions and having different types of monopolar homopolar links that can be held over the future aspects times. The hydro integration and offshore virtual labor standardization of development researchers also have a road over the efforts standardization of HVDC grid system. Conclusion of empty HVDC multi-terminal HVDC system backbone sustainable energy. Multi-terminal HVDC systems are positionized and backbone of sustainable energy global future for rapid technology advances control uh, converter over the technologies that pulled over successful pilot projects. Worldwide research having challenges spanning over technical innovation and regulatory frameworks over collaboration and commercial validation of multi-terminal HVDC system. these connecting and balances used for the sustainable energy future. Thank you.